So functions in topology are supposed to be continuous. So this means that, roughly speaking, it means that if points x and y from, so if we have a function from A to B, so and if 2 points x and y belong to A, and if the distance from x to y is small, right, so they're close to each other, then it means that f of x should be close to f of y, roughly speaking. For sets that are subsets of a Euclidean space, so if A is a subset of Rm and B is a subset of Rn, then you know the notion of continuity from calculus 3. Calculus 3. So if A and B are not necessarily subsets of a Euclidean space, well, then it is also possible to define what a continuous function is, and we will do it a bit later in lecture 3. So this has to do with a so-called topological space, right? But for today, let's just, I don't know, let's just either pretend that we kind of intuitively understand what a continuous function is, or you can pretend that all sets that appear in today's lecture are subsets of a Euclidean space. So here is the main definition, right? So a function from, well, x to y, so x and y are supposed to be topological spaces later, or today you can just pretend that x and y are both subsets of Euclidean space. So a function is called a homeomorphism if it is bijective, continuous, and the inverse function is also continuous, right? So this is the central notion of topology, and this was the noun homeomorphism. So a homeomorphism, a noun, means a particular function from x to y, and we say that x is homeomorphic to y, so the adjective homeomorphic, if there exists some homeomorphism from x to y. And of course, if there exists some homeomorphism, then there will be a lot of different, so infinitely many different homeomorphisms usually.